to this today. My plan for tomorrow is you haven't done the advanced piece of the last performance task. So I was going to give you time to do that, and then also time to work on the homework assignment from tonight and tomorrow night, okay? Since I'm not going to be in class tomorrow. And the advanced piece is basically you're going to take another group's and you're going to try their problem. So it should take you about 15 minutes and hopefully you'll be done with it. Okay, I'm going to start talking about it. So, a function is a relationship between two variables such that each value of the independent variable there corresponds exactly one value of the dependent variable. So, what that means is that for every x, there is one and only one y, and that makes it a function. If there's more than one y, it's not a function. Okay, and we're going to go through some examples and some pictures and all that kind of stuff to show you some of those things. Okay, y is the dependent variable, x is the independent variable. Domain is the set of all input or x values of the independent variable for which the function is defined. Okay, if x is in the domain of f, it's said to be defined at x. If x is not in the domain of f, it's said to be undefined at x. Okay? So if domain is the inputs and the x values, range has to be the outputs and the y values. Okay, so domain is x, range is y. I remember it because it's alphabetical order. D comes before r, x comes before y. Okay, assume that the dependent is assumed by the dependent variable, and that is it's the set of all the values of the function. Implied domain is if the function is defined, if f is defined by an algebraic expression and the domain is not specified, the domain consists of all real numbers for which the expression is defined. So if they don't tell us what the domain is, we assume it's all real numbers, unless there's something that would put a restriction on the domain. Square root functions put a restriction on the domain because there's values that are undefined. Okay, so that's the only time when we have an implied domain. Last period in zero period we had an implied domain that popped up. Okay, with a radical function. All right. I know there isn't there's a little bit of space in there to the right of these symbols. We're going to talk about how you write the domain in the range there. Okay. So, if you have a solid dot, okay, so it's a solid dot or a solid line, that's when we draw brackets, because we're going to learn what we call interval notation. We kind of touched on this when we did the last performance the roller coaster performance task. Okay. So that's what we call a closed, okay? If it's open, so it's an open circle, okay? Or you have arrows, that's when we use these parentheses, okay? So I'm going to talk about the domain and the range. I tend to abbreviate those D and R, okay? What values is the domain? The x, okay? So I'm going to go I always start from the left or the bottom, okay, depending upon what am I doing. So I'm going to go to the most left value. What's my smallest x value? -1. Is it an open circle or a closed circle? Closed. So I use a bracket and I go -1. And then I go all the way to the other end of my function. To that point right there. That's the last point in my function. Is it, what's my x value? 4. Is it an open circle or a closed circle? Open, so I use a parentheses. Okay? It looks weird, but you gotta get used to it. This is the way notation is written, and you gotta kind of get used to the fact that this means all the way from the x value of -1 to 4, not the point -1, 4. Okay, so you gotta start switching your thinking. That's no longer necessarily just a point. Okay. All right, range. I'm going to start from the bottom. So now I'm going from the bottom to the top. Range looks at the x values or the y values? Y values. Okay, so what's my smallest y value? -5. Is it open or closed? Closed. So I start with a closed -5. I'm going to go all the way up here to the top. What's my biggest y value? 4. It's going to be open or closed? Closed. Even if that dot wasn't there and it was just this solid kind of curve, I would draw it closed because it definitely stops there. Okay? There's no arrow, there's no open dot. Alright? So that's how you write the domain and range. It might ask you for that. We're not really doing a ton of examples that have that possibly, so there's a little mini example on that. Alright, we got some more blanks to fill in. So go ahead and fill in those blanks. Now, the last part of this box, the purpose is more for when you go home and you don't remember what to do, read the box. Okay? So, I'm going to talk about it and then we're going to do some problems. The problems will do everything that's in that box. So when we're finding the domain, you want to consider any values that are not allowed. So, for instance, other than an imaginary instance, we can't really put a negative inside a root, right? Inside a square root or an even root. Inside a cubed root, we can have a negative in there. Alright? Numbers that will make the denominator of a fraction 0 are also things that might be issues with the domain. Okay? In those cases, we can say all reals except wherever the denominator is equal to 0. Determining if something is a function. So one way we can determine if something's a function is to see if a set of points is a function, plot the points, and see if they pass the vertical line test. So this quick and easy vertical line test, okay? I'm sure we're going to run across one here in a few minutes, but vertical line test is basically if I have a function on a graph, I can take a vertical line and draw it through the function, and it doesn't hit more than one point. So the parabola passes. What about a circle? Does a circle pass the vertical line test? No, so a circle is not a function, all right? Hopefully you've seen the vertical line test before somewhere, okay? Maybe in Algebra 1. If you took Algebra 2, definitely. See if an equation is a function, solve the equation in terms of y, get y by itself. For any one x, there can be more than one y. If for any one x, there can be more than one y, the equation is not a function. So every x only gets one y. If there's more than one, it's not a function. You often run into this when you take the square root and end up with a plus or a minus. So likely if you get a plus or a minus, whatever you're getting is not a function. Okay? If I had done the circle formula, equals 5, I would eventually have had to take a square root here, which would have made it a plus minus. That makes it not a function. Okay? Alright, so we're going to describe the relation. Does the relation describe a function? So remember, your key to doing this is you're checking that each x has only one y value. And then it's either yes, it's a function, or no, it's not a function. So, looking at example 1, and this is what we call mapping, okay, when you see these arrows. So I would take I take my x values and I draw an arrow to their y values. In this first one, do all the x values have a unique y value? Okay, the 4 goes to 5, the 5 goes to 2, the 7 goes to 3, the 3 goes... Do they each go to only one y? Yes, do, right? Each one goes to only one y. It's okay that these two go to the same y. That's all right, okay? But they cannot both go to the 1x cannot go to 2y. So this one, yes, is a function. You're going to see the difference in b, okay? Okay, 4 goes to 2, 5 goes to 3, 7 goes to 4, and 5. Does each x go to only one y? No, so that one is not a function. Do we see the difference? So this situation here is okay if I get 2 arrows pointing to a y. This over here, x with 2 arrows, not a good thing. Okay. All right, let's look. Similar thing, different context. They put it in a table instead of in a little mapping thing. Okay. So I need to make sure that each x only has one y. So I've got 0 going to a 4. I've got 1 with a 2, 2 with a 1, 1 with a negative, or sorry, that was with a negative 2, that's with a positive 2. So does that work? Yeah. Okay, let's think if I drew the arrows. I have 0, it's supposed to go to negative 4. I have 1, it's supposed to go to negative 2. I've got 2, it's supposed to go to 0. I've got 1 again, and now it's going to go to 2. Does it work? No. Do you see how if you drew this out and that could help you? Okay. Cole, do you have a question? We have different numbers. Oh, okay. That doesn't work very well, does it? All right. So looking at the numbers you have, so the one I have wouldn't work. Okay. Let's look at the one. Does yours work? No, it doesn't because of the zeros, right? So you had 0, negative 4, 3, negative 2, 2, 0, 1, 2, and 0, 4. So it's good in the middle, right? Middle's good, but because I have 0 going to both negative 4 and 4, that kicks it out. So is it a function? No. And if you wanted to explain the reasoning, because 0 has 2 y values. It says explain the reasoning. All right, let's keep going. Alright, it says which sets of ordered pairs represent a function from A to B. So A is basically your x, kind of like your x values. B is kind of like your y values. That's what I'm guessing this is coming out to be here. So I just am going to look at the sets of ordered pairs and make sure each x has a unique y. Okay? So, 1, do I have any other 1s? No, so that's good. 3, do I have any other 3s? Yes, so does that one work? No, so this one is not a function, so that one's no. Okay? If you need to, because there's 2 3s. 2 3s, or 2, because 3 has 2 y values, right? That's how we were saying it before. That says values. Okay, looking at B. Do any of the x values repeat? So is that one a function? Yes. All right. 15 seconds. Try C and D. Look and see if the x values repeat at all. All right. What about C? Is C a function? Yes. C works. What about D? Is D a function? Yes. Okay. All right. Determine whether the equation represents y as a function of x. So basically, when it says y as a function of x, you want to get y by itself. By itself. Okay? If we run into the plus minus thing, it's not a function. Okay? If we don't run into it, it likely is a function. Okay? And I will show you probably also in the calculator, is my guess. Yeah. Okay, so I am going to do what to get that 1 to the other side? Subtract it. Okay, how do I undo this squared? Square root it. Whenever I undo a squared, I have to put a plus or a minus. So because I have the plus or a minus, is that a function? No, that one is not a function. So, not a function. Okay. Alright, let's take a look at example 5. Let's take You're not going beyond the building, so. Alright, and the one that's, there's 2 use a plus or a minus, so yes, it's a function. Alright, I want to look at it really quickly in the calculator, okay? So we're going to put the first one in. So everybody do it with me, okay? So I wanted you to be able to see it to do vertical line test on it too, okay? Alright, I'm still there. So I'm just going to go to my scratch pad. So in here, actually, I wonder if you can do, let me see, menu, nope, not that one. Is it there? Other graph, equation. No, you still have to have it solved for y. Never mind. Okay, I was going to see if we could get it in as a different thing, but we can't. So we're just going to go with the way it is. Okay, so what I have to do is I have to put in each one of those branches individually for the first one. So it was, one of them was square root. Square root's above the x squared, right? So control square root. It was 1 minus x, wasn't it? Is that right? I'm going to double check what I wrote down. I'm doing the first one, not the second one. It's x minus 1. Okay, yeah, I subtracted the other direction. Okay, let me fix it. Okay, so we want x minus 1. That's going to change things a little bit. Okay, so that's the picture of the top part. Now I need the negative of that, don't I? So I'm going to go to my second one and I'm going to type in negative square root of x minus 1. Now that gets me the whole parabola technically on its side, right? So, is that something that would pass the vertical line test? If I drew a vertical line through there, it would not pass the vertical line test, right? And again, we had to do the plus or minus thing to get it into the calculator, so it is unlikely to be a function. So it does not pass the vertical line test. If I drew a line, it would hit the function twice. Alright, let's type the other one in. So get rid of these two. You could do a doc B, right? Doc B clears the scratch pad. Okay, and the second one was negative x squared. X squared, and it was plus 1, right? Is that one going to pass the vertical line test? Yes, so that one is the function, is a function. So you've seen the vertical line test with graphing if you need it. And again, if you ever get confused and you have a graphing calculator at home or you get online, type in free graphing calculator, okay? Put it on the graph, okay? That helps. That's sometimes how I have to do calculus problems. I'll put it in the graph to get kind of a, and not have to do everything. So, what does this mean that I'm going to plug in for the y? 0. So I'm going to write, and I would write it, g of 0 equals, and I'm going to plug 0 in where the y is. What's 3 times 0? 0, so what's my answer to that one? 7. What does it say I'm plugging in for the g, the y this time? 7/3. What happens? The 3's cancel, so I'm left with 7 minus 7, which is 0. Okay, now it gets weird, right? What does it say I'm putting in for the y this time? S plus 2. So it's kind of like substitution method, right? Okay, I should probably simplify that. What am I going to do? Distribute, so I get 7 minus 3s minus what? 6. So I get negative 3s with 7 minus 6. 1. It's an s, not a 5. Okay. Let's look at, I'll just talk about it. I want to do the last part of this next one. What would I do with this 2? Plug it in. What would I do with the t? So I would make me swap all the signs. Let's just do part C, okay? Because part C is the part that gets tricky. Be careful here, the negative is on outside of the squared. So anytime I see the x squared, what am I putting in? x plus 2, okay? And so I see a 4 and with an x, I'm going to put in another x plus 2. What does this mean we do to the thing? Yep, it means we FOIL, that's right, okay? At the same time, I'm going to go ahead, well, I'm going to skip a line. I'm going to FOIL here, okay? What is x times x? Good, what's x times 2? 2x, and I have that how many times? Twice, so what's 2 plus 2? So my middle is 4x, what's 2 times 2? 4, good. What am I going to do with this 4 here? Distribute it, so I get 4x plus what? 8. Drop down that 1 at the end. What do I still need to do with this negative sign? Distribute it, so I get negative x squared minus 4x minus 4. I lost an x here, didn't I? Right there. Okay, plus 4x, what's 8 plus 1? 9. Okay, so if I simplify one more step, I get negative x squared. What happens with the 4x's? Cancel. Negative 4 plus 9 is 5. Yeah, not too terrible. Alright, the next one's a little bit strange. Oh, I don't have that in the right place. We're going to go here. 8. So, okay, look at the instructions. What does it want me to set the function equal to? 0. This is way algebra 1, isn't it? Set it equal to 0, solve it. So negative 1, x equals what? Negative 1/5. Okay. Looking at 11, I'm still going to set it equal to 0, aren't I? I multiply by 7, what happens? What's 7 times 0? 0. It's kind of back to algebra 1 now, right? 2x equals 3, x equals what? 3 over 2. Okay. Next one. What is it saying to do with the two functions? What's this say right here? It says make them equal to each other. Okay, so that's what, so set the two functions equal to each other. Equals 7x minus 5. Okay. Gotta get it equal to 0 because it's a quadratic, right? So we've got x squared. I'm going to move the 7x by subtracting. What do I get? Negative 5x. What am I going to do to move the 5? And what do we get? 6. Alright, what am I going to have to do to solve it? Magic x, two numbers that multiply to 6 and add to negative 5. So we have x minus 2 times x minus 3 equals 0. Good old zero product property. Can you do it in your head? What's x equal to? 2 and 3. The only thing we hadn't done before yet this year was set those things equal to each other, and that's not that big of a deal. Okay? Alright, we have to find the domain. So the domain is at the x values or the y values? That's the x value. So we're looking for the x value. So in this first one, and when you have this bracket notation, we list the domain in brackets. All I want you to do is write down the x's. So what are my x numbers? 0, 2, 4. Done. We want like 100 of those on the next test, right? Alright. What kind of a shape is a squared? No, a squared. What kind of a shape does a function that is squared make, you guys? A parabola, thank you. Okay? So, a parabola looks something like that, doesn't it? Is there any x value a parabola is not defined for? It's got arrows, doesn't it? Doesn't it go on forever and ever in both directions? Yeah, so we would say that the domain of this is all real numbers. Because remember, that's what way back at the beginning of the notes it said, if all else fails, it's always all real numbers. Okay? This one right here, it has a denominator issue, right? Okay? So with that denominator issue, it would be all real numbers except where that is equal to 0. So I'm going to take that denominator and set it equal to 0. So where is it not defined? -5. So I would say all real numbers except x, or sorry, it's not x, y equals -5. It's weird that they have a y in there. Normally it would be an x. Alright, the next one says volume of a sphere. That's kind of weird. Okay. Are there some values that we don't use typically in geometry for a radius? Can a radius be -3? No. Okay. So this would be where R, I would probably, because it says R, I would say R has to be greater than what number? We want positives. 0. Good. So that's your domain for that one, is R is greater than 0. Okay, radicals are weird. Radicals, I would always set it equal to 0 and solve it. Okay, and that will tell you what your domain is. Okay? Actually, I'd set it, we want it to be bigger than 0. Okay, I would do that symbol on it. So how do I undo the square root? Square it. So we got 4 minus 3x is greater than 0. What am I going to do with the 4? Subtract it. Yes. Subtract it to the other side. I squared it. When I square 0, I get 0. When I square a radical, I get rid of the radical. How do I move the divide by -3? So we want x, and I have to swap the sign, right? That's not correct. I shouldn't have put the inequality sign in. Let's lose the inequality. I want it to be, my inequality sign's the wrong direction. I'm going to leave it as equals. Alright, so we know that it's that, okay? So that's my exception. Here's the problem with a radical. A radical always is a picture is like that. So really, this is the beginning point of where the function starts. So I would say it's x greater than 4/3. If it was a negative, it would probably be it would be okay. Oh, it's the negatives on the inside. So you're okay with always doing a greater than for right now. Okay. All right, let's keep going. Use the graphing utility to find the domain and range. Awesome, we get to put that in our calculator. So let's type that in real quick. Again, if you don't have it at home, you could do a T-chart. You could go online, find free graphing calculator. Okay. At some point here, we are going to have some in the library to check out. Some of the old ones. Okay. I'm going to do a doc B. All right. And we had to put in, it was square root, right? Square root of 9 minus x squared. Alright, it's half a circle, right? Okay, where's my beginning x value? -3. Where's my ending x value? +3. Alright, let's, because it wanted me to find domain and range, right? So go ahead and sketch that really quickly. Okay, I'm going to sketch it too. This is my favorite part of this whole thing. Yep. Copy. Paste. There we go. Beautiful sketch. I know. I'm good. Alright, so the domain, and this is where I would use the interval notation that we just learned. Okay, what's my smallest x value again? -3. Is it open or closed? In this context, we're going to pretend those are closed. Okay, so I would always go closed if there's no official arrow. If it's ending, it's closed. Where's my biggest x value? 3. Okay, range. I want my smallest y value. So think at the bottom, what's that y value right there? 0. Good. Open or closed? Closed. Good. What's my biggest y value? 3. Good. Open or closed? Closed. Alright. We're going to try to finish this.